exactly is troubleshooting? Well, troubleshooting at its essence is identifying a problem and then resolving that problem. As a super simple metaphor, think of driving your car down the street and your car stops. And you're not sure why you want it to go. That's a problem. To help resolve that problem, you can start to gather information. For example, you might look at the instruments inside of your car and you notice that the gas gauge says that you're empty. Well, based on that gathered information, you might hypothesize that the reason your car stopped is because it's out of gas, and then you develop a plan of action. Your plan is to put gas in the car and see if that helps. Well, you test out your hypothesis, and sure enough, that makes the car go again. And when we're talking about troubleshooting computer networks, it's really the same thing. We want to clearly identify the problem, gather information surrounding that problem, analyze that information, sift through the information, eliminating things that just are not relevant, propose a hypothesis, and then test that hypothesis. And if our hypothesis is wrong, as it will be oftentimes, not a big deal. We'll just go back and we'll come up with another plan. And once we do resolve the problem, we'll want to document what we found. In fact, Cisco gives us a step-by-step model we'll see in our next video that's going to walk us through each of those steps. But here in this introductory video, let's talk about some different approaches to troubleshooting. Some approaches to troubleshooting are based on the OSI model. For example, we could do top-down troubleshooting. With top-down, we're starting at the application layer or the upper layers and working our way down. As an example, let's say that somebody is not able to get to a web server out on the internet. What we could do is go to their computer and verify the problem. We'll make sure that we're seeing what they're seeing. We're not getting to that site on the internet either. And if we can reproduce what they're reporting, maybe we try other sites. Is this a widespread problem where it's not just this one site that's unreachable, it's every site on the internet? If that turns out to be the case, we might open up a command prompt window on their machine and telnet to a web server's IP address on port 80, the HTTP port. And if we are able to connect on port 80, that's going to give us some assurance, not a guarantee, but it's going to give us some assurance that we're good at layers 1 through 4. Meaning that we need to focus in on the upper layers. Maybe that browser is misconfigured. We've typed in an incorrect proxy server as an example. If we're not able to telnet to that site's IP address using port 80, then we might need to focus our attention on lower levels. Another approach is to use a bottom-up approach, starting at the physical layer and working our way up. Here we're looking at things like cabling. Is the device plugged in? Is the router plugged in? Is the switch plugged in? And if it is, we can move up to the data link layer where we're making sure that our switches have learned appropriate MAC addresses. Then we can move up and make sure that the routers know about routes to get to a destination network. And the first example that comes to my mind thinking about a bottom-up approach is I was doing some network support for my church, and the secretary would occasionally call to say that her computer and only her computer could not get out to the internet. Well, I'd walk through a few things and I'd say, all right, I'll be out and check it out in a couple of hours. But before I went, she would call back and say, oh, it's all working now. Oh, okay. And this went on, and there were all these intermittent issues. Well, finally, I went into her office to take a look at what could be going on. And have you ever seen those plastic chair mats? And they have those plastic spikes on the bottom that dig into the carpet. Well, she had one of those plastic chair mats underneath her office chair, and running underneath that plastic chair mat was the Cat5 cable going to her computer. And those plastic spikes had punctured the Cat5 cable. And this Cat5 cable was super flat where she had rolled over it again and again with her office chair. That was an example of a physical layer problem. But generally, the approach I'll begin with is more of a divide and conquer approach. This is where we're not starting at the top, we're not starting at the bottom of the OSI model. Instead, we're starting kind of sort of in the middle. We go in and we separate the upper layers from the lower layers and we do a ping. Can I ping the destination that is unreachable? Ping uses ICMP. We send an ICMP echo request. And if we get an ICMP echo reply, we know that we have reachability to that IP address. Now, technically, ping or ICMP is a layer 3 protocol. It does have some layer 4 characteristics, but technically ICMP is a layer 3 protocol, and if the ping works, that's going to give us some assurance that the bottom 3 layers are working, and we can start focusing our attention on the upper layers. If the ping does not work, if it fails, well, that's an indication that we need to focus on the bottom layers. Am I physically connected to my switch? Can the switch see its neighbors? If I do a show CDP neighbor command. And let's say the ping did fail. Another troubleshooting approach I might use at that point is to follow the path. Let's go out to a live interface and take a look. One way to follow the path is to use the traceroute command. In the example on screen, let's say I go to router R1 and I'm trying to get to the IP address of 3.3.3.3, the loopback IP address on router R3. I could enter a traceroute command specifying 3.3.3.3, and it's going to tell me information about each hop along the way to this destination. Notice that my first hop is 10.1.2.2, that's R2, that's my next hop. Then I go to 10.1.2.6, that's R3. This is telling me the router hops I use to get to 3.3.3.3. I go into R2 and then I go into R3, and that gets me to 3.3.3.3. However, let's say that there was a WAN failure between R2 and R3. Let's go into R3 and let's shut down interface serial 1/0. Let's say interface serial 1/0. We'll do a shutdown. Now we should not be able to do a trace route to 3.3.3.3. Let's issue the command again, and this time I still go to 10.1.2.2, but notice I'm timing out after that. I'm not able to get beyond router R2. Well, that's actually useful information if I'm doing troubleshooting. That tells me that I can start focusing my attention on router R2, and specifically the link between R2 and R3. I can get to R2, but I cannot get from R2 to R3. That's going to encourage me to go to R2 and check out things, and go to R3 and check out things, and see why those two devices are not communicating with one another. I might go over to R2 at that point and do a show CDP neighbors command and see that I do not even see R3 at layer 2. I only see that I'm attached to R1. And I could do a show IP interface brief command, and I could check the status of the serial 1/0 interface on R2, and we could see that we are up, down. We have a connectivity issue with R3, and then I would go in and start checking the interface configurations on R2 and R3, and I would find that, sure enough, R3 has this port that is shut down, and I could do a no shutdown to bring it back up. That's an example of how we might follow the path in order to isolate what's going on in the network. Yet another approach to troubleshooting is to compare our baseline configuration against the configuration that we see right now. Let's say that the configuration snippet that you see on the left of the screen is from my baseline documentation, but the configuration on the right is what's configured right now on the router. Maybe we swapped out a router and we tried to reconfigure it just as it was before, but something doesn't match up. How quickly, if you've not already spotted it, how quickly can you spot the difference? Well, you might have noticed that that very last line, the IP address command for interface serial 1/0, the baseline on the left has a 30-bit subnet mask. In other words, 2 IP addresses would be usable on that subnet. Maybe this is a point-to-point link. But if you take a look at the configuration on the right, it's got a 32-bit subnet mask. In other words, there's only going to be one usable IP address on that subnet, 10.1.2.6. That's the difference. We need to be able to spot the difference between a known good configuration and a configuration that we have right now. And one other common approach to troubleshooting is swapping out components. Let's say that a PC cannot get to its default gateway. What could be wrong? Well, it could be a bad switch port into which this PC is connected. We might try a different switch port. We might even, during a scheduled maintenance window, swap out the switch. And if swapping out the switch fixes the problem, we might have had an issue with that original switch. Maybe we swap out the fiber jumper going from a switch to a fiber patch panel. Or maybe we replace the Cat5, Cat5e, or Cat6 cable going from the PC into the wall jack. And we could also move different network components. We could swap Cat6 cables as an example and see if the problem follows the cable. We've got 2 PCs, one's working, one's not. Let's swap the network cables and let's see if the problem follows the cable. Well, that's a look at some really common troubleshooting approaches, and what we want to do in our next video is take a look at Cisco's structured troubleshooting model.